Welcome to today's video on NAT, or Network Address Translation. Before the internet grew into the monster it has today, there was thought to be enough IP addresses to cater for all devices at the time, and for the future. That figure is 4,294,967,296. Before NAT was introduced, every device was given a public IP address. So looking at the diagram, each device was publicly reachable on the internet. This was not a good use of address space, as has been found out. To address this, IPv6 has been created, but in the interim, Network Address Translation was created. It is an excellent solution which is being used a great deal on many networks. In this diagram, we can see there is now only one public IP address, and within the Green LAN network, there are many private addresses, and these are not allowed on the public internet. They are called non-routable addresses, created by the IETF. In today's tutorial, we will be configuring NAT in a network simulator called GNS3, on the router on the right of this network. There are three elements to NAT configuration, as follows. 1. Configure NAT on the internal and external interfaces of the router. 2. Configure an access list which will allow the internal network to access the internal interface for translation. Lastly, 3. Configure the external interface for something called overload, where multiple internal IP addresses are mapped to one external interface. I will be creating a separate video on how to create a small network in GNS3 at a later date. For now, we are just going to focus on NAT and how it is configured. GNS3 is very simple to use, and we can drag and drop various network devices onto the stage. I have placed a NAT cloud on here, as this will connect via my laptop, directly to the internet. I bring a router onto the stage, and this is the device that will be connecting to the cloud, using NAT. I'll be using a small switch to allow a PC to connect via the switch, out to the internet. The VPCS is a small PC image and is perfect for simulation. GNS3 allows us to connect all of these devices up by using the Add a Link icon. I start with the router and select the F0/0 interface and connect this into the NAT cloud. The F2/ interface connects to the Ethernet switch. Finally, the E1 port on the switch connects to the PC. I line the devices up as I am like that and tidy the devices up for housekeeping, then click on the black square with letters to show the labels of the interfaces. The first configuration is on the router, and we must configure NAT on both the internal and external interfaces. I use configuration terminal, then move on to the F2/1 interface. For good housekeeping, I label the interface as LAN facing. We are giving the LAN address as 192.168.10.1 with a subnet mask of /24. However, as this module is a switching module, we need to remove the switch port config. Use the up arrow to apply the last command, and we are set. Just one more very important command, and that is the IPNAT inside command. Unshut the interface and it will come up slowly. This interface is now ready, as the logs show F2/1 state changed. The next section is creating an access list to allow the LAN network to access the internal interface. This is called a standard access list and is very simple. Call this access list 1, followed by permit IP address of 192.168.10.0 and a wildcard of 0.0.0.255. As with all access lists, we have to apply this to an interface, and this references the outside interface. IPNAT inside, using the source list 1 command, followed by the outside interface, and for translations to occur, we use the overload command. One element I actually forgot was to apply NAT on the outside interface of the router, or all of this will not function. A quick show running config on the F0/0 interface confirms this, so I move to the specific interface and type in IPNAT outside to complete the configuration. To finish up again, and for good housekeeping, I save the config using the write memory command. I now have to move to the PC that is on the network, so that we can test if this connects to the internet. It's labeled PC1, and I console into it to carry out some simple config work prior to testing. It does not use a GUI, Therefore, using the CLI, I use the IP command, followed by the IP address on the 192.168.10 network. It's followed with the default gateway address of that network, which is the 192.168.10.1 IP. The config was successful, so save the config. We can now see if the PC has a pathway to the internet by testing the Google DNS IP address, which it does. Moving back to the router, we can now prove that network address translation is taking place. The R1 router connects into the NAT cloud and will allow the LAN addresses connect. This is shown in the command, show IP NAT translations. There are inside local and global addresses and outside, all followed by port numbers for that session. As you may have noticed, we are only pinging IP addresses, but what about website and host names? On the PC, I will try to ping my website address, GFL Solutions, which does not work. There are two places we still have to configure, so head back to the router and within the global config, we need to type IP domain-lookup. The second command is IP name-server, and we are going to use the Google DNS server, 8.8.8.8. Save the config as you go. As you can now see, I ping google.com and it responds with its IP address successfully. Can we do this on the PC? We need our users to be able to reach the internet, but it still does not respond when using the hostname. On most networks, there is either a DNS server locally or we use Google. The same applies here for this PC, we configure it locally by using the IP DNS command. Now, there we go, we can reach google.com. I'll test my own website as well, to make sure. Looks good to me. This must mean the NAT translations are also occurring. So show IP NAT translations confirms that the configuration is perfect. Thank you so much for watching this video today. If you have any questions, just drop us a line or comment below. Like, share and subscribe to the G-Man channel and we will see you again very soon.